Hey, in this video, let's add another feature where we can visit animals and they can do different things based on which kind of animal they are. This is going to require a new programming feature, dynamic casting. So let's talk about that. In our last video, we had added a feature where we could buy animals and actually fill up our farm. That's pretty cool. So now I'd like them to do stuff. I'm going to add a new function in here and a new option in our menu. So here I have when the player is asked to do something, they can buy animals, feed, visit, quit. I'm going to add another option in here. Let's push quit down further to 5. All right. And I want option 4 to be pass a turn. So wait a while. You could be more specific, because what I want to do is wait for a little bit of time. Let's say do pass turn, and I think I'm going to do it based on a 24-hour clock. It's not going to really have much of an impact other than a turn has passed, but we're going to I'm going to at least keep track of the time that's passing and say like every turn is 8 hours, so 3 turns is a full day. Okay, do pass turn. Let's write that function. So when you pass a turn, it should say 8 hours pass. And then we want the current time, so current time plus equals 8. So we'll just keep track of the hours that are passing. I guess it makes sense to start. Let's create this variable, current time. Make that here, current time. And let's say we start at 8 o'clock in the morning. And then it'll be 16 o'clock, and then when it's 24 o'clock, that's when we need to wrap back around to 0 o'clock. And I'm sure all that makes sense the way we commonly talk about time. But let's say if current time is greater than or equal to 24, then let's subtract 24 from it. Okay, that should make our wraparound work correctly. 8 hours pass. cin.get. So that is fine. I also want stuff to happen here. I want all of my animals to get a chance to do something, or all of my buildings, or whatever else is in my farm. So farm dot pass turn. Okay, let me get to my farm. Pass turn. So we'll go through our entire grid just as normal, and if this spot in the grid is not null, then that object should do something. Pass turn. Okay, let's add that pass turn function to our grid object, this base class, so that every grid object can do this. And by default, I actually have default functionality here. By default, I want pass turn to do nothing. I don't want buildings or animals or whatever to do anything when we pass turn, but only special animals really need to respond to this, or special buildings. It could be that every animal does do something on pass turn, like maybe they have a food counter that ticks down and they get hungry. and die or something. That could happen. But I'm going to make the default do nothing, and then just the chickens for now are going to be special. I want chickens to produce eggs, and they should produce 1 egg every day, which means every 3 turns. So I need to keep track of that time passing in my chicken. So time until egg. And then chickens should also keep track of how many eggs they have, so they can gather up a bunch of them. So this is information that doesn't really need to be public. I can put this into a private section here. Nobody's going to mess around with my eggs right now, and I'll add functions if I want them to do that. So these are uninitialized integers. I need to add the constructor to initialize them. Time until egg. Let's just always put it, let's just always put it at 3. So it takes 3 turns. Num eggs, set that to 0. And then when we pass turn, we will subtract 1 from time until egg. And then if time until egg is, just be careful, less than or equal to 0, then reset it. Time until egg is 3. And then num eggs plus plus. Let's add an egg. Alright, so now every turn, chickens are going to generate an egg, or at least, well, I mean, that's what we call this number. It'll be just a number. Every 3 turns, they add 1 to this number. And so let me add some functions to access the num eggs as well, because I'm sure I'm going to need them. Let's see, int, let's say get num eggs. Okay, that's the number of eggs. I'm labeling it as const because I know for sure this should not ever change the chicken by asking it how many eggs it has. And then let's say collect eggs. So collect eggs will modify them. Let's save how many eggs we have, set that number of eggs that we have to 0, and then return the eggs that we did collect. That should work. Great. And so notice these are functions specific to a chicken. No other animal has these functions. And so somehow we're going to have to, if we want to interact with a chicken specifically, we're going to have to find out that it's a chicken, and that's what we'll do. Okay, so let's go all the way back up. We have pass turn, which is generating eggs for our chickens, and then we need to add a way to kind of visit our chickens so that we can get their eggs. So in our farm, it's not here, in our game, do visit, there it is. Right, so I want to ask the user to choose an animal that they're going to visit. Which animal? Okay, I kind of want to, I do want to clear the screen, but then I want to draw the farm so that they can see what their options are. Alright, prompt. I'll need a string to catch what they say, and then I have to figure out what they said. So if input is something, then we do something with that. So we'll figure this part out. What we need to think of is, what is the user actually going to type in? When we play this game, what the user sees is a grid, and when I go to visit an animal, which animal, and it shows the grid. The user doesn't know what to type in. We have to tell them what to type in. So let's adjust our drawing function so that it labels these grid slots. We could say put like numbers along the top and letters along the side and try to figure it out that way. And then they have to type in a combination of letters and numbers. Is there a better way? I guess we can do it that way. We have to make sure that they know which order to put the letters and numbers in. So let's say in which animal, e.g. A2. So they'll type in something like A2, and that's what I'll be checking for. Okay, farm. Let's print out a little differently now. Before I print it all out, I'm going to have to print out the numbers along the top. So this will be 1, 2, 3, and 4. I'm just guessing on the spacing. I'll figure it out. Okay. And then along the left edge is a little tougher because that means I'm going to have to add space in front of everything. A couple spaces on these lines. And then this is the beginning of one of these rows, right? For each column. And that's the separator for the row. The beginning of the row is right here. Okay, so we're going to have to make letters out of this row number. So each row is going to correspond to a letter. 0. So let's do a little bit of funny funny math here with characters. If I take the letter A and I add 1 to it, it's going to become B. If I add 0 to it, it's going to be A. And so on. So I could add the row to this character value in single quotes, and it should adjust it properly. Let's see if that works out. I also want a space. So there will be 2 spaces, or 1 character and a space. All right. I think let's try that. Okay, so it's looking close. The numbers need to be adjusted so they line up a little better. This printed out numbers instead of characters, so doing that math looks like it turned it into an integer. So let me cast it back into a character. Okay. A few more spaces there. Let's cast this back into a character. That's better. Oh, that looks nice. Okay, good. So now we'll get our animals filling that up, and then when we visit an animal, it asks us which animal, e.g. A2. A2 would be this spot here. And so I'm going to have to look for their input and interpret it. The first character they type in is going to be a letter. The second one is going to be a number. And I'm going to have to enforce that, and I'm going to be very strict about what they type in. Where is it? Do visit in game. Okay, there it is. So, if I'm going to check to see if this is the right size of string, the length of the string. I could use length or size, they're synonyms here. If the size is not 2 characters, then we're going to return. We're going to end our visit and go back to the main menu. I'll just drop them right back to the menu without saying anything. Probably not the best UX. I could print something out and ask them again. If input size is not 2, okay. So now after this line, we know that input size must be 2. There are exactly 2 characters in this input. So now I can check them. The first one is going to be input 0, and then the second one is going to be input 1. And now I need to modify these so that they are the values that I expect. This one first, I want to treat it as if it is a letter, right? Okay, so if first is less than A, or first is greater than, what's our last one, D? So if it's outside the range of letters that I'm accepting, then we'll return. That's not appropriate for them to type anything other than this range. If second is less than 0, the 0 character, mind you, this is not integers yet. We have to convert it to an integer. Or second is greater than it's not 9, hold on, and it's not even 0. We go 1 through 4, those are the possible options. So if it's outside of that range, let's return. They're not allowed to do that. And now we know first and second are valid characters within the range that we want them to be. So now I could test them directly for these characters, or I can convert them to indices into my farm. So the first index is going to be first minus A, right? Yes. So A minus A is going to be 0. That's going to be the 0th index for our row. And then I could even call this row index. First minus A. If this was D, we'd get 3, right? Yep. All right. And then our column index is going to be second minus the character 1. Make sure they use the character 1, not the integer 1, because that means totally different things. Okay, this character minus the character 1 is going to give us another index, and then we can access our grid using those 2 indices. Okay, what are we going to do there? So we choose which animal to visit. So now we can set up a new prompt. Let's clear the screen and let's print something out about this animal. First, I'm going to get that animal, or whatever it is. Okay, column, row. Okay, and I guess it matters if there's no animal there, if object is null. Let me say something really facetious. Okay. Wait for them to press enter, and then we can return from this function. Okay, so now we are now guaranteed we have an object in this spot. what can we do with it? Let's see what grid objects are capable of. Get name, so we can ask it for its name. Okay. UCA, and then what is it? OBJ get name. Alright, UCA get name. Other than that, like if it's an animal, then I can kind of keep going. So how do I check to see if it's an animal? If it's a building, I kind of want that to just be it, or if it's not an animal for now. So I could add a function. I could add a function to grid object that returns a Boolean and says whether it's an animal or not, and I can override that in the animal class to return true, and have it default to returning false for all other grid objects. Or I can do this this special cast. So let me animal star animal. So let me make another pointer to an animal, and I'm gonna try to convert this object to see if it will fit into this animal class, or this animal pointer. To do that, I need a cast. This is an upcast. This is a cast from a base class up to one of its, or down, I don't know, direction, to one of its derived classes. So I need to use an explicit cast. And for this, I'm going to use DynamicCast. This is a special cast that only converts pointers. It can only be work with pointers, and it works with inheritance hierarchies. So we have a grid object base class, animal that inherits from grid object, and we need to know, is this particular grid object an animal? So we'll cast it using DynamicCast, which does runtime type identification. It is checking when you're running this. It checks to see what type that that object is. If it's an animal, then this succeeds and you get a valid pointer to an animal. If it fails, then you get null. So I can check for that. If animal is null, then that's not an animal, and we can just let them press enter and then return back to where we came. Alright, now we know at this point we definitely have an animal, and I can get some more information out of it. So let's say, what do animals have? Animals can speak. So let's make our animal speak. The animal says, okay, what am I missing? Speak, oh, I see. So speak does not return a string, it just prints out things. Okay. Alright, so that's fine. So it'll speak on the next line, and then let me put a new line, and then let's see. There are actions that I could do with animals, but what I really am interested in right now, because I haven't added any special functionality for other animals, I want to see if it's a chicken. So let me do another DynamicCast. Okay, to a chicken. DynamicCast to a chicken pointer. Cast this animal. Alright, if chicken is null, then that's not a chicken, and we're kind of done. Just wait for them to press enter, and we'll return. Alright, now we can say the chicken has Now we can actually access it as a complete chicken object. It has get num eggs. And I guess we could put a menu here. I was thinking it would be more complex than this, but we could just tell you you collect the eggs. Okay, that's fine. I'll just keep it simple. You collect the eggs, and by doing so, we need to have some sort of number of eggs you've collected, but I'll just give you some money. Worth some money. So let me tell you how much money you got. Let's say like 3 for every egg. Chicken. Get num eggs. Those are expensive eggs. A single egg costs $3. Okay, whatever. I don't care. Okay, and now I want to collect those eggs, which will give me the integer number of eggs that I actually collected, and it will remove those eggs from the chicken. Did I make it do that? Yes, num eggs equals 0. Good. Alright, removes those eggs from the chicken, gives them to me, and I can sell them for $3 each. Crazy. I would love to get that much money for my chicken eggs. Okay, other thing here, this is going to be a little weird when you have 0 eggs, so I could do some special check here. If there are no eggs, that's all we need to know. Otherwise, let's make some money. Okay, alright, let's see if this works out. Let's play it. Okay, cool. Let's buy an animal. Let's get a couple of chickens. Let's go back. Let's let's first visit an animal. I want to visit A1. Animal says cluck. Chicken has no eggs. Okay. And let's pass a turn. Okay. Let's pass another turn. Let's buy a chicken. Alright, so chicken number 3 is new. Pass another turn, and then let's visit our chickens. Visit an animal. A1. Chicken has 1 eggs. I collect the eggs worth $3. Oh, that's cool. So now it doesn't show me how much money I have here, but if I go to buy, yep, I got some $3. That looks good. Let's go visit our 3rd chicken. No eggs. Good. Let's pass one more turn. Let's visit that chicken again. A3. No eggs. And one more turn should give us an egg on the 3rd chicken. Visit A3. 1 egg. Visit A1, no eggs yet, and then let me pass a couple more turns, make sure that eggs can build up. Visit A2, 3 eggs, making bank. Alright, well, I think that's it. From here, we can go a lot farther with this game, but I think we've seen a lot about inheritance and polymorphism, dynamic type checking, runtime type information is what that's part of. A lot of useful stuff here that should help you out with your projects. All right, I will see you later. Chicken